Stage is yours.
Mm-hmm. Yeah, thank you very much. So as Philip already mentioned, we just started collaborating or having a joint brainstorming session together between AUTOSAR's working group safety and ELISA, mostly I think the automotive group. So what I thought was maybe we can just present what we do as part of the working group, how we're organized, divided, and our activities there. And then one of the subgroup is represented by Wolfgang. Then he can elaborately tell what we do there and how we connect to the ISO 26262. So that's basically the main purpose. I would like to start off then with the slide deck where I would like to mention that we are divided as working group safety into 3 different subgroups, namely the end-to-end protection subgroup. In brackets, I've written they work mostly on the topics of safe communication. Then we've got platform health management, which who works on mainly the topics of safe execution. Then we've got the functional safety architecture subgroup, which would be represented by Wolfgang, and later on even has more elaborate slides than the ones that I have here. And we look at the whole architecture. Yeah, most activities currently are on adaptive platform, but of course our group is responsible for both classic and adaptive platform. So I think it makes sense if I try to make a good connection between our activities and the ISO 26262. So one of the things on which we started working in terms of safe communication are those communication faults mentioned in the ISO 26262 Part 6 Appendix D, which mentions that the faults during exchange of information might be one of those: repetition of information, loss of information, delay of information, insertion of information, masquerading, incorrect sequence of information, corruption of information, asymmetric information sent from the sender to multiple receivers, the other way around, information from a sender received only by a subset of the receivers or the intended receivers. Then a very common one, blocking access to a communication channel. So that's basically the scope or the mandate for our E2E subgroup. And the solution within AUTOSAR was the so-called end-to-end protection, where we have different profiles to detect multiple communication faults. And those profiles, namely 1, 2, 4, 5, 6, 7, 8, 11, 22, 44, 4M, and 8M, have been specified or standardized so far. There are still some upcoming in this year's release. And each of those profile has a combination of different parameters with different lengths of those parameters, or bytes or bits of those parameters. The major 4 parameters, a combination of which makes a profile, are length, which might be of 16-bit, 32-bit, then a counter, which might be of 4 bits, 8 bits, 16 bits, 32-bit, data ID, which might be of 8 bits, 16 bits, 32 bits, and CRCs with different standards and polynomials. Then we've got some 3 additional parameters, which are specific to the M profiles, that are message type, message result, and source ID. Yeah, so that's basically the scope of end-to-end protection subgroup within AUTOSAR Consortium. Then we move on to the safe execution. Again, I would like to take a snippet from the ISO 26262 Part 6, specifically 7.4.12, which mentions monitoring of program execution by an external element, such as an ASIC or another software element performing a watchdog function. Monitoring can be logical or temporal monitoring. So the AUTOSAR solution in adaptive platform is the so-called platform health management for this, and in classic platform, it's the watchdog manager. And within these mechanisms, we have different supervisions, namely three main supervisions. A live supervision, which basically checks whether the safety relevant process is still responding, is it alive or not. The second one is then the deadline supervision, where of course you have perhaps hard deadlines for some tasks to be performed, and whether they are performed within these times. If not, then this is reported further for some kind of recovery actions. Similarly, there is now the other part of the ISO 26262 statement, the logical monitoring, where we have logical supervision, which functions with respect to checkpoints, going through the whole control flow graph. And we see, okay, this is a graph which should be followed. And if it is corresponding to that, then everything is good. If there is some kind of a deviation or a failure within this logical graph, then again, there is a recovery action that is triggered, or at least the process to start this recovery action. So that's the mandate for our platform health management subgroup. Then we've got the safety architecture, or what we call a safety functional safety architectural subgroup. It also has a couple of tasks, a bit more abstract than safety mechanisms, as did E2E and PHM. Two of them are basically organizational. So working group safety is one of the 4 lead working groups in AUTOSAR. What does lead working group mean? It means that we need to check for functional safety impacts. And there are 2 ways how things can come into AUTOSAR. One is through change or bugs. We call it, change control, or the change requests scenario, or the change requests workflow. The other one is through an incoming concept. And for the bugs and changes, a member or a couple of members from working group safety, specifically from the subgroup FSA, sit in the change control board and vote for each and every change from a functional safety perspective. Similarly, when the concepts originate, the first milestone is basically presenting it to the lead working groups and getting the review points from them and working on those. So they are normally also presented in our weekly meetings, and one of the members within the FSA subgroup, they take a look at it, review it, and give their comments on that. Then the real doing part of the functional safety architecture, which would be much more elaborate in the next session that Wolfgang would present. So what we thought was, okay, provide a high-level guidance in the light of ISO 26262 towards AUTOSAR, for which we took a similar structure of the ISO 26262 and created 2 main documents, one being the explanatory safety overview. So explanatory would mean that it is for the sake of explanation, as the name suggests, but does not have formal requirements in them. There we start off with taking, we don't have really a product, so it's not exactly what people would think of having HARA analysis, FMEAs, and so on their product. But we thought, okay, we take this architecture as a safety element out of context, and we give a bit of a system description, basically the natural habitat of AUTOSAR, where would those kind of issues lie, typically in vehicles, their environment around them, and a very abstract kind of a hazard analysis, fault failures or fault models that can happen. Then we've got safety goals at a very high level. And from that, we derive the functional safety concept. So all this majorly as an explanation, but I guess that's not enough to ensure safety at this level of mechanisms at a platform level. And this is why we also have then the RS safety which is a formal requirements document which has top-level safety requirements. And from those top-level safety requirements that we think are basically targeted towards AUTOSAR, we have we try to make functional safety requirements, and those functional safety requirements, the level of abstraction, we thought, okay, we can have it at an abstraction level which corresponds to both adaptive platform and classic platform. But we don't talk about the mechanisms, and then technical safety requirements are derived from those functional safety requirements, where we even talk about the individual solutions or the mechanisms that are existing in the adaptive platform and the classic platform. So for example, OSIC would be a known operating system from the classic platform, and POSIX would be the one for the adaptive platform. So we'd be a bit more specific here. Similarly, what I showed previously, platform health management is adaptive platform terminology. A similar terminology would be watchdog manager, and we would be mentioning those explicit names here in technical safety requirements. So basically that is it from my side, and now I'm open to questions before I hand it over to Wolfgang.
At least from the chat, there have not been direct questions. I don't know if someone wants to speak up and just put the question directly. Would be also possible. Otherwise, I would say we just move over. Or Shui, do you want to ask something?
Yes, one question. Thank you. This is very helpful. I was wondering, do you have any use cases and practical applications that you can elaborate on?
So your voice was quite low. I don't know. Did you get it to Cypher?
Yes,
Good.
regarding the use cases. So the use cases, basically that's probably something also what Wolfgang would like to elaborate on, but what I can tell is the use cases are no different than the AUTOSAR's use cases. Specifically, when I talk about adaptive platform, the targeted use cases are, the over-the-air updates and autonomous driving. Similarly, car to X communication and so on, which requires high performance. And as some might arguably know, that sometimes performance and safety has to come into a compromise, and those topics also come here, for which I would then also take the next question, which was what ASIL level you are aiming for. So the idea when the adaptive platform actually originated, I can say for classic platform, of course, they are in field. They have a long history before them. It's quite stable. You find ASIL-D ECUs having classic platform. When the adaptive platform started, the idea was originally, okay, let's target up to ASIL-B, since more concentration should be on the performance, and it's also not a replacement for classic platform. So the more safety critical functionalities could lie in the classic platform, whereas the more performance oriented could lie in the adaptive platform. Then the working group safety had a different opinion here. We thought, okay, one of the major use cases is autonomous driving, and without being able to have an ASIL-D, it's probably not possible to have an AD system. And that's where we said, okay, we give our guidance here, and but AUTOSAR is reluctant to say, okay, that is an ASIL A, B, or C, or D level functionality feature, etc. But we leave the choice open to the integrators and provide everything we can with respect to mechanisms, as well as with respect to guidance, where we came up with the whole idea of explanatory safety overview and RF safety. I hope that answers the question. The next question I see from Gabriel is it possible to add documentation links reference to the deck so that we can dig better offline? Yes, I guess I could do that. I'm just not familiar with what would be the formal process of that. At least I know from our meeting with ELISA, we had given a few links with respect to the RSOSI, so operating system interface, execution management, and also the RS safety, where we said, okay, please take a look at it from an operating system perspective and give us a feedback. I also recall there was a bit of comments that we got in our last discussion with ELISA, but yes, at least the released versions I could later on also put in the chat when Wolfgang is presenting.
Yeah, I guess this is basically what Gab was also interested in, is that we have the link to the release documents.
Okay, I could do that.
Great.
And then I think that's a good point in time that I give it over to Wolfgang.
If you're talking, at least I cannot hear you, Wolfgang. But I can see your slides.
Does it work now?
Yes. Yeah. Now it
Fine.
works.
Yeah, I searched for the unmute button after it disappeared.
Good.
Can you see the screen?
Yeah, it's visible.
Fine. Then hello, welcome. My name is Wolfgang Schramm. I'm working in the work group safety for a few years, and I will present you something, a little bit of detail about the safety overview document and the safety requirements document and the structure we are working on in the functional safety architecture subgroup. Then starting, so basically that is our document structure. So in AUTOSAR in general, there is an RS main document where basically quite high level AUTOSAR goals are derived, and one goal is AUTOSAR shall support safe systems. Question is, what does it mean, a safe system? So we invented, or we started creating a safety overview document after long discussions. I think since AUTOSAR is a very particular concept type as in being a middleware, providing some functionalities and providing interface specifications. It's not really a complete safety concept or an item in its own. So I think safety overview was in the end catchy enough to say, let's collect something according to the system engineering development topics, according to the ISO, and aligning something with the idea of a safety concept, but describing basically assumed context of the AUTOSAR platform. So what is in the ecosystem around the software part? I think we have vehicles and we have ECUs, and then on the ECU we have microcontrollers. And then somewhere we have then the AUTOSAR below an application and with an OS in the context. Then we derived top-level safety feature requests based on some use case. Here we all have to struggle between what are use cases then on a vehicle level and what are safety features and also in an abstract sense, as Husreifer already presented with what failures can happen and so on. Somewhere in the execution of a software or in the vehicle context, which basically we or the partners know. Then we identified basically the hazards resulting from it. I think hazards are then resulting in the use case of an item. I mean, a software itself or an ECU is typically not harming someone. So basically the main item is harming someone. So we need to at least theoretically go back to the idea of is there an harm, or is it just an abstract way that something can go wrong if you have a communication mistake? But basically, with a high-level use case, we can really argue in a certain with a certain product and a certain functionality, something can really go wrong. This is encaptured, or ideas encaptured in the safety use cases. That is a document which already exists for classic platform, is currently in an phase where we extended to adaptive AUTOSAR use cases. Also on a mixed level, something like a higher level perspective. What is the purpose of AUTOSAR being used? So which high level context and which applications we think it is meant for, and also then abstract it down to the specific safety measures and functionalities provided. So what is the appropriate use, for example, of E2E and the implementations? What is the appropriate use of the platform health manager, with the idea of keeping it back to a justification on a high level? So that I think is a common goal, which helps in the understanding of what was the purpose of the safety measure of the interface. Based on that, we also have the RS safety. So, for example, this is then the formal safety document providing then traceability from RS main. Then we have RS safety in between, which is a collection of safety requirements for AUTOSAR. Top level safety requirements, basically more in a goal-oriented interpretation, and then functional and technical safety requirements, basically, which can then be traced by the individual basic software modules for classic or functional clusters or services in the adaptive platform. So basically, for the history, basically on a vehicle context, I mean, as already said, we have starting with a vehicle, so that is the root of all danger. Basically, in a vehicle, we have multiple ECUs, and in ECUs, we have currently these days several CPUs and cores, and several virtual machines or computer programs, which results in different items. So here also then we try to distinguish then between AUTOSAR Adaptive and AUTOSAR Classic. They have a different systematic goal in mind. Typically AUTOSAR Adaptive platform for more performance-oriented controllers, and AUTOSAR Classic platform for low latency microcontrollers. I think typically that is where it often comes down. And also then basically from simplicity, the OSEC OS and some items maybe are easier to rate. This depends, future will show in a certain ASLD context or not. But that's basically then where the question runs come, which ASLD, which ASL is supported. Depends on also on the implementation, on the specific OEM's problem, on the complete vehicle design setup, on the decomposition, which defines you in the end really what do you need and what do you require as an individual vehicle manufacturer or control unit manufacturer. And spinning the gap to ELISA, basically in AUTOSAR Adaptive platform, we have a POSIX OS. So basically, we need a safe and secure operating system, which provides us functionality, because AUTOSAR itself is not providing everything. It's an industry consortium providing the most common functionalities, which basically are interested in being standardized either for a software stack provider, and also to have a clean interface to basically concentrate as an OEM or as a function developer on the application and less on the middleware. That is basically then something which is then intended to be bought. So that applications within the AUTOSAR ecosystem can be exchanged. That is the whole idea. So AUTOSAR is not just a software level definition. It's basically a whole system context where AUTOSAR application could in theory be deployed in any AUTOSAR compliant ECU. That is also the idea. And then this configuration and code generations and interface descriptions, it should be in theory easy to realign or create a different deployment. Then going in more detail, basically in the software context, because we have the AUTOSAR Adaptive application, the AUTOSAR Adaptive platform, which provides interfaces for applications. So the application should never have direct interface to the underlying hardware. Also is an API or an interface according to the OS, sort of. Then AUTOSAR Adaptive platform cannot run without an OS, as we know. I think AUTOSAR needs some sort of interface to non-volatile storage. We need interface to the network stack. So AUTOSAR Adaptive is not providing a TCP/IP stack. Depending on the operating system, topic. Either the stack is part of it or it's an independent thing, but basically not provided by AUTOSAR in the end. Then we need a process API. There, AUTOSAR defines that they are requiring basically a POSIX compliant API. So basically all internal AUTOSAR adaptive platform function clusters or modules are developed or should be developed according to that in theory. And then we need multi-process system interfaces, also then message calls, signals, how do processes communicate then with each other and so on, how to start processes. That's all then some sort of an interface between OS and adaptive platform. So basically still the OS starts processes and AUTOSAR is managing, monitoring, triggering it to a certain behavioral description and creating then also the appropriate diagnostic messages. So everything which is relevant for the automotive world and the customer and the end user in the end is then provided by AUTOSAR in the defined standardized methods. Okay, then assumed high-level safety use cases. As Josef already said, basically automated driving, which needs, I think that is one of the big use cases for AUTOSAR adaptive platform, because this needs a lot of computational performance. And I think in the automotive world, basically it's challenging, but I think we need to realize such an automated driving system, multiple computers, multiple in-vehicle systems, for example, then multiple sensors or sensor ECUs for perception, and also multiple high-performance computers for maneuver and trajectory planning for various reasons. Either one computer doesn't provide enough resources, or it gets too expensive, or it gets too hot, or we need multiple ECUs for redundancy concepts and so on. And all of these needs to be synchronized. So here then AUTOSAR already provides system health management, for example, and other methods. So it's not just a concept for one implementation. AUTOSAR provides a concept and a systematic idea for basically more than just one ECU, also ECUs talking to each other and monitoring each other. Then another use case could be an instrument cluster, can be done with AUTOSAR adaptive or classic, depending on your ASIL statement. It's also a subsystem within a vehicle to publish safety relevant information for the driver. Could be in connection to an automated driving system, for example, that an automated driving system, if it has a fault, it needs to publish basically something to the instrument cluster ECU, which creates what is it? An LED or a signal to the driver to tell the driver to take over. Basically, if the driver doesn't take over, it will result in a crash. So basically, even with that communication already, it gets potentially safety critical to have this item. And based on your system design, either your automated driving ECU can trigger that signal directly or indirectly via communicating. But everything is also then irrelevant without a safe brake system. So here typically that's an operational range in actuator control and so on. That is a subsystem which provides braking and steering capabilities, typically the domain of AUTOSAR Classic, but also safety relevant. So we try to capture with our document the whole basically both items, AUTOSAR Classic and adaptive, and basically figure out which safety measures are needed in software in an automotive world. And then in the technical requirements, split then from the functional topics towards the dedicated platform requirements in the specific solution provided by AUTOSAR. Which leads us to the top level feature requests derived then in such a context on an abstract level, which means AUTOSAR shall support safe program execution, which is then provided by control flow for monitoring and watchdog, as already mentioned with PHM and watchdog manager. Then we have exchange of information, which is a critical part. Also, this can be solved with the end-to-end protection in communication. Then we need safe data storage. There we provide data identification mechanisms and data integrity checks, so that basically the appropriate item is then retrieved from the storage, and this is then managed by AUTOSAR and the configuration. Then we have maintain configuration. typically which software is on the vehicle, is it the right ECU, which information is it, which applications to run, what are the right version informations, so that and to be safe that this information has not been tampered with in the meanwhile or is corrupt. Also, this is basically then also an item which needs to be checked. And then we have a system update, which also needs to be in the safe way. So where we describe basically a guidance, which in which system level states basically AUTOSAR or some experts think that it could be done. For example, safety critical items should only be updated while the vehicle is in a safe state. If you think your system is safer than that and you can update your AD software while driving in AD, let's see. But even that is then system integrity checks and processes which are needs to be done. So even then checks if the vehicle manifest and overall ECUs is then in an appropriate format, or if all versions are correct, and also AUTOSAR defines processes in the end, or relies on processes. So basically, if there is a wrong configuration, we end up just with a wrong configuration. If the computer cannot check that anyway, it does not do. I mean, there could be self-tests, there could be version controls and other comparisons. But in the end, a lot of topics, I think, will end up being if there is a wrong configuration. Hopefully it does not result in an error, or basically it should be tested even offline before deployment. So also safety processes needs to be followed, no deployment of an untested software, and being careful about updating your system configuration. And all for multiple mixed criticality applications on the same or another platform. So that is an important part. So on the same platform, we have then mixed criticalities to maintain, where we also then need the support of hardware. We need the support of then also the OS for memory protection, memory management units, virtualization concepts, and so on, depending how the system designer intends to design his system. This leads us then also already to RS safety. Basically, the top-level safety requirements we fed up with, as said, is more in the idea of a high-level goals or concept needed or expected from AUTOSAR. So that's a collection on based on these features, which are basically giving the idea of these are the items AUTOSAR is trying to support, to manage somehow. Then we created functional safety requirements. Basically safety measures or functionalities required to provided by AUTOSAR. So basically things which we defined then are these functionalities needs to be done by AUTOSAR, I think, based on the experience in Classic. And since adaptive already started, we had some reverse engineering to be done, and some abstraction which functionality is already provided, and try to capture that in a way that it fits then in the end both to adaptive and Classic platform. And then we end up with the technical safety requirements, which addresses then the dedicated solution, either guides you then through the adaptive platform or the Classic platform, defines you then the basic software module, the function cluster or the service. The idea is here with this document to give the safety engineer a proper collection of items to see which items are safety relevant, which items provide which safety function, and with a basic understanding of a vehicle or a control unit in software, basically, that he understands with the goals. That is the idea, that is the concept, safe communication, how is execution management working, and so on, and then deriving it a little bit more into functional safety requirements in between. As a short example, I think we had already some feedback from colleagues from ELISA. I think also internally we struggle a little bit with that, so that is then a new one, not yet written in, but basically that is then the idea. AUTOSAR should provide mechanisms to support execution of multiple applications with mixed criticality in the intended order, which provides basically a high-level viewpoint, what is expected, what is the idea. Then as a functional safety requirement, AUTOSAR should provide safe transition of states in application or service and life cycle. That I think is also depending on a safe transition of states needs to also be followed in the right order. In the end, if you have multiple applications, and to solve that problem, that applications states are then done, state changes are done in a safe manner. We go back to the platform health management. So basically the purpose of the platform health management is to monitor the control flow of safety relevant applications and services. So here basically this ends up that also the state monitoring. So which item, what is the that the functionality is not jumping around and doing the proper thing in the proper order. Okay, then that was it from my side. Any questions?
We already have one in chat from Shua. It was basically dropped in there when you were talking about over-the-air updates and how to handle configuration system integrity. It says, does AUTOSAR make recommendations on architectural elements, saying like partition-based system upgrade, or is there anything considered like this? So
I can probably take that, and then Wolfgang or Yoav, if you guys like, you can also elaborate on that. So there's a general part of this question, and then there is a specific one. So basically, AUTOSAR is the AUTOSAR or the automotive platform, or the standardized platform, and of course, it has a lot to do with architecture, high-level explanations, and then coming through typical architectural decisions. We have even started documenting them from the last release. I would post a link for 2 of such documents in the chat. One thing that I can say specifically about, about classic platform was with respect to partitions, it was quite, let's say, a big chunk due to the RTE, and there was no possibility of partial upgrades in that sense where you could have cut that. And we had another concept last year, which was classic platform flexibility, where we divided them into so-called software clusters to make the upgrade there easy. Adaptive platform, on the other hand, was always thought of to be much more flexible in these terms. And we have defined some rules. A software cluster update, what we call, would be a typically an update that is sent to the adaptive platform, and it might have several functional clusters being updated, applications, configurations, and so on, with a few let's say constraints or groupings. So yes, there is a recommendation. So I post the 2 links with respect to the explanation on software architecture in AUTOSAR. I think they're specifically currently for adaptive AUTOSAR, and then also architectural decisions. Meanwhile, Wolfgang and Yoav, if you would like to elaborate, please feel free.
so either struggling with a mute or no further comments on this.
No, I think that's basically it. I think they are in classic platforms extensions being made to be more to support more partitions. I think there is this partitioning concepts in classic, and in adaptive, I think anyway with the memory management unit and higher level microcontrollers or microprocessors, we have more options, but also virtualization concepts are supported. I think there is no real recommendation about how to do it. That is in system definition. What is your argumentation in the end about your application, about the criticality? Also, system update concepts needs to be made by the ECU designer, by the OEM. Do you know in advance that you will have a product which needs to be updated later on? So I think that you can also choose appropriate design to simplify updates of software items later in the field. I think these days with wireless connections, it's easier than maybe 30 years ago, where you'd have to go to a workshop and then it's easy to flash everything. I think these days you might just to update your radio application.
So I also see another question with respect to the AP release, is there an AP release that meets all these functional safety architecture requirements? So basically technical requirements. It's an evolution process. So last year we were able to successfully request other RSs to uptrace to the first set of requirements or technical safety requirements that we had so far. So in R2011, you see this, and it would be an evolution process, as I say. So it would keep on maturing for this release and the next release. And we will also start elaborating our requirements or putting on more technical safety requirements.
If I read this question, I think here is some fundamental part. The work you're doing in the AUTOSAR consortium with the adaptive platform is that you provide interface description and that you provide certain guidance, but it's not that you will provide the implementation of the AUTOSAR adaptive platform stack. This is task of the integrator, right? So that is more that you form the frame that others use this as base for the implementation. And if you would like to see an adaptive platform release, software release, usable, then you would go to other companies, right?
That's right. If you read the question in that context from product perspective, then yes, the whole idea was that we have all these safety related requirements in a one document that we can give to a functional safety engineer who's working in the area of AUTOSAR mostly for the stack vendors, and they ensure meeting of these safety requirements in their product. I would think it's a bit too early that they might have released R2011 compliant products with all of these mentioned safety requirements.
Okay. There's some more question. Is AUTOSAR adaptive platform taking care of this requirement coming from hypervisor, or is it from future? I guess it's more, we can maybe get this in a more general part for the hypervisor field. How are you just putting anything to specific or else? How are you dealing with hypervisor technologies and so on?
I think there is a concept currently elaborating that topic. If there needs to be something to be done, or if hypervisors need a specific interface, depending then also maybe on the abstraction levels. I'm not too familiar with the elaboration. I think in our technical proposals in the safety overview, we didn't say anything against or towards it. Since if it is mapped transparently from AUTOSAR, it might work even without AUTOSAR knowing it. But maybe there are some use cases already known from the industry partners that that's not that easy. In that way, I think that's why we have this concept in the end to define, are there interfaces, specific interfaces for hypervisors needed? So that's currently in analysis.
Okay, thanks. A very nice question also, which is coming quite often together these days for safety and security. So there's a question from Sanjay who's asking if there are any consideration for security in adaptive AUTOSAR. So is there
just
a
like
security group or?
Just like working group safety, there's a working group security, which is also a lead working group. They similarly have mechanisms for security. I think what they currently don't have is such an overview document of security, but that probably might also be related to the fact that the safety standards in the automotive industry they're not considered as holy as ISO 26262 for safety. So that's why the direction there needs to be, or the strategy needs to be well formed out upfront. But yes, definitely there is security, there are security mechanisms.
Okay, and there's something more. I guess John was asking if there are requirements or mechanisms to achieve freedom from interference. So anything put there? I guess FFI is also some element which I saw somewhere in the docs.
Yes, basically everything is around freedom from interference sometimes, but with which specific one to clarify which mechanisms, for example, is the memory protection unit or memory management unit for process isolation and so on. So I think we can use the freedom from interference term in a general way. I think what we try to figure out then is that is basically a reason to be more precise and more specific in the end to declare what is AUTOSAR providing or what is the automotive industry requiring to achieve freedom from interference according to basically the input we get from an AUTOSAR from the partners, and also then what is then the individual product requiring to achieve that. So I think AUTOSAR might not provide everything. I think that is in the classic sometimes ways, and there are specific solutions provided by the stack vendors, which are not yet standardized, but sometimes going to be standardized. So I think everything here is also in a process. But I think the goal is always to have freedom from interference for the criticality topics. So that, but the term is an important point is to point out how do we try to achieve freedom from interference.
Okay. And there is one more. What is roughly covered from the safety documentation by the reference implementation? I remember there were some examples for E2E, maybe some software watchdog. Could you provide a hint there?
Mm-hmm. Yes, so just for the background, and Cornell has a very good background in adaptive AUTOSAR, especially with the implementation. So we, in the adaptive, or when the adaptive platform started, we thought, okay, we should probably also make some kind of a prototype implementation that we can use for verification of our standardization rather than the long process of stack vendors implementing that and coming back to us with change requests and bugs. And this is what Cornel is referring to. And yes, with respect to end-to-end protection, we had some challenges in the beginning where we had an implementation of taken over from Geneva some IP, and we thought of putting plugins for E2E, but yeah, the whole legal scenario wasn't so good. So we thought, okay, let's have our own implementation of the some IP, which was given to us by one of the partners. And now the idea is, at least in this release, that we try to, I guess it's profile 4, correct me Ines if I'm wrong, that we try to implement that and provide that as part of the validation. Similarly, for platform health management, there is I think that the implementation there is much more mature compared to the E2E one, where we've got some mechanisms of supervising a few adaptive applications and also of recovery actions. But there was an architectural change for the recovery actions, which needs now to be followed in this reference implementation. So yes, there is an implementation going on.
And the implementation, the reference implementation, runs most likely on Linux, or which OS you're taking for reference implementation?
Yes, we take the Yocto project, have our own flavor of so-called POSIX. Where we have a recommendation that adaptive applications shall be POSIX E51 compliant. Functional clusters may use higher level standards.
Mm-hmm. Okay, and it's good. The questions popping in. That's nice. Are there any recommendations for usage of ASIL decomposition? I think the word came once or twice. I don't know if there's any guidance also there or respect to AUTOSAR. A question for you, Wolfgang.
No, I think we don't want to create a reference architecture for that. I mean, the ASIL decomposition depends on so many factors. So it's quite hard. I think for middleware, we need to try to abstract topics to the software world alone to have a justification for high level. So we need some root cause, but I think the decomposition, how you should do it, what is recommended, I think that's outside of AUTOSAR for now. I think there are projects providing reference architectures, which suggestions how to decompose your ECU design, how to decompose some things depending with what is your risk, what is your risk level, or what is the risk you want to take and can take. So that's a little bit tricky. So we we don't define ASIL levels. We have an idea in mind. Also, we don't give any guidance for decomposition, but in the end, we know that there will be decomposition. So we need to provide some sort of mechanisms in the end to support certain strategies.
Shua was also asking how the actual implementation looks like, and you provide verification tools or verification code. I guess this goes to what there in the reference stack, most likely, and how this.
Yes, we have our GitLab where we put our code. So basically, it's more or less in C++. Again, as I said, utilizing the Yocto project. There is, with respect to tools, I don't know how much tools you expect in AUTOSAR. Compared to that, our code is purely code. Everything is quite raw, code oriented. And yeah, the tooling support or the tool implementation is then the bread and butter of the stack implementers, stack vendors.
Sure, I'm not sure if this was exactly the question that you were asking for, if you also want to get more ideas on other elements.
Do you provide?
Yeah, that's good. Thank you.
Okay, good. Okay. So, we see that if I missed a question, copy paste it again, but I guess I touched all of them. Have just 3 minutes left until the next session starts, so it would be a good chance because we see the first people leaving. I want to say big thanks to you for presenting the status of the AUTOSAR working group safety and the different field subgroups which you have. It's very nice. It gave a very good overview, and we can see from the question there's a good interest in it. And yeah, the set I will say maybe we see the one or the other in the automotive loaded afternoon today. I think there are a lot of automotive related sessions. With a similar interesting background as this one. I definitely want to come back to the next AUTOSAR session as well. So in the AUTOSAR virtual face-to-face or at some point of real face-to-face to meet you there. And yeah, thanks a lot for speaking here today.
You're welcome. Thanks for inviting.